So I guess before I get into my presentation, I wanted to give you guys a demo. How many of you here were at GTC or saw the GTC demonstration that was done with the Octane Cloud Render? One person, two people. OK, well, then I guess I'll start from the beginning. We're OTOY. We're a cloud rendering company. And that can mean a lot of different things. In our case, we're working to move graphics rendering into the cloud and applications as well. So what I have here is really a demonstration, I guess, of that in principle and in practice. We're inside of a Firefox web browser. There are no plugins. This is just pure JavaScript. And I'm rendering a scene from 3D Studio Max. And I'm rendering it with our unbiased GPU renderer called Octane. And Octane is currently a standalone product that you can buy and download. In this case, though, it's running in a web browser. And it's running with 3D Studio Max. And because it's in the cloud and it's just a web page, I have unlimited compute power at my disposal. I don't just have to be limited to 1, 2, 3, or 4 GPUs inside of a box. I can have hundreds if I want. And in this case, this scene has 60 GPUs. So rendering this scene on one GPU might take a little bit of time. It may take a couple of minutes. But on the cloud, it's this fast. It just takes a couple of seconds. And that's pretty neat from the perspective of anyone doing movies or visualization. I can, in fact, move the scene around live, and you have an instantaneous render. So this is very powerful. This is unbiased path tracing. This isn't just ray tracing or a normal viewport render. This is actually final render being handled in real time. And the other thing that's fascinating about this is that you really do have the ability to have this entire control happening inside of a browser. So for us, we're delivering this service as a web service. And that includes not just the rendering that we're providing, but also the ability for developers to build applications and content around this. So I think that this kind of technology is going to be very interesting going forward. You've heard a lot about NVIDIA's grid technology, and how that can be used to stream Autodesk applications. And this really builds on that to deliver that to a web browser. There's really nothing stopping developers and artists really from leveraging unlimited rendering compute power through a service like this. We can deliver virtual desktops in the same sort of way. Opening an application is as simple as really opening up a link in a web browser page. And because it's running entirely in JavaScript, let me actually open another link here, the kinds of devices that can receive these streams are varied. So this is a model from Transformers. It's streaming and rendering in JavaScript at 60 frames a second. And if I wanted to, I can also open up the same link on my phone over 4G. Let's see if I get a link here, and it'll work as well. I don't know if you guys can see this, but really, there's absolutely no client to get all this to get this content and this data. It's running entirely in a browser, and having this as a web service really does allow the ecosystem of web services to be built around this system. So you have a lot of CAD applications in the cloud being built with WebGL, and this really can enhance that and provide rendering and other services like compute on demand in a web browser page. So with that, I wanted to get into a little more detail about our core technologies. And chief among those is Octane Render. So you guys were seeing the Octane running live. But Octane's actually been out for a couple of years now as a standalone application. And we've had a lot of great content built with it from our beta testers. And now it's been out of beta for about 9 months. And we have plugins for every single 3D application, pretty much. And our goal was to get that to that point by the end of this year. So all the Autodesk applications pretty much have a Octane plugin, Max, Maya, Softimage. We're building one even for applications like Motion Builder. We this year released a Lightwave plugin, Cinema 4D. We're about to push out Blender. And we are also targeting a couple of new ones. So we have Rhino in the works. SketchUp will be done by the end of this year, as well as Modo. So going back to Octane, I think what makes it very special is how fast it is and how high the quality is. For GPU render, that's a really interesting milestone. We can basically render anything, right? You've got caustics and scenes like this that are very complex, and these really just take minutes to render, and on the cloud they take seconds. So this scalability is something that couldn't and didn't exist before CUDA made applications like this possible. We released Octane's first beta in 2010, right around the time that compute cards and GPUs became powerful enough to deliver a renderer like this. There's a number of interesting properties in Octane that I think separate it from a lot of other renderers. One of the things is that we do have several different modes for ray tracing and path tracing. There's a direct light mode for very fast renders. That's, in fact, suitable for a lot of these kinds of renders, like the ones you're seeing here for architecture. But when you get to doing things that are more, that need to be physically correct, we have a full path tracer, and then we have something that's equivalent to Metropolis light transport, which allows you to do very complex interiors and spectrally correct rendering. And spectrally correct rendering means that, for example, things like gold that change the frequency of light as it bounces, all of that is handled correctly by Octane, and it's handled very quickly. And that is something that a lot of production renderers don't do. In fact, a lot of production renderers skip caustics, or they cheat, or they do brute force GI. And I think the beauty of Octane is that you don't need to do any of those things. You get a physically correct, unbiased renderer that can render a scene in 2 seconds. And I didn't really talk about the cost of rendering, but if you don't want to invest in a GPU on your own machine, you can pretty much render what you're seeing there on the cloud for about $1 an hour. That's what we're essentially providing Octane in the cloud as a service for, per GPU, right? But you can also scale all those GPUs together, and you can have one GPU for, render a scene for an hour, or you can take 100 GPUs together, and for the same cost, get that exact same render back in 1/100th of an hour. And so cloud rendering is a very interesting model. It changes the entire way that people can think about the cost of rendering, and it applies all the way to big production studios, all the way down to end users. And right now, Octane is, been targeted towards end users, but we're just starting to see, adoption in films and big productions. And our first partner in that regard which was announced at GTC, is Fox with Fantastic Four. And we provided them with early access to the cloud rendering service. And we also have their artists on their own machines using Octane. But anyway, this is a great render. I wanted to sort of show this off. This is showing the spectrally correct rendering that we have in Octane. There's instancing, so that allows you to have really unlimited amounts of geometry without worrying about the limits of GPU memory. And thanks to NVIDIA, which just put out a card yesterday that has 12 gigs of VRAM, we're getting to the point now where there's not going to be very many limitations in terms of the amount of data you can really fit into a 12 gig system. We're also looking at being able to do out-of-core rendering in Octane down the line. That'll allow you to use system memory for maybe a 4x speed hit. But all in all, this is a pretty exciting leap forward. I mean, when you look at CPU rendering and the amount of resources and time it takes versus what you can do on a GPU, it's 10x faster with Octane, or 40x, or even 100x. And this is something that we've seen time and time again. Now, there are, I think that people have known for a while that GPU rendering is a lot faster, but to be able to get this quality, and we don't even make a CPU renderer of Octane. There's no need to. This is really a big breakthrough. We just recently released Octane 1.2, which added volumetric lighting and fog, which you're seeing here. And this is showing God rays, which is, again, very exciting. You can also see the instancing at work. We also have subsurface scattering in Octane, which is something that also is really not easy to do in a GPU render that's this fast, but allows you to do very complex skin and organic effects. And I think that really does, cover a huge amount of what you'd want to do with with a render for everything from, architectural design to movie rendering to character animation. And Octane really does cover all of that, and we don't cut any corners. So no compromise rendering in real time is really what we're targeting, and it changes the entire production workflow. I mean, obviously now when you look at a viewport that is grayscale or doesn't have physically correct materials, and you imagine the iteration cycles that artists have to go through before waiting to get back a render of this quality, it changes the entire way that directors and even previs is done, and that's one of the things that we're really targeting with Octane is we want to make the pre-visualization process essentially the final rendering process as well. I mean, there's obviously many sort of loops in that chain, but when you, as an artist, you can see the final render inside of a viewport from your laptop, from your iPhone. That does make the entire workflow very different. So we have a couple of announcements that we're also making today and at the show in general, and one of them is what's coming next for Octane. So Octane 1.5 is around the corner. And Octane 1.0 was released, late last year, And Octane 1.5 really is sort of a very big milestone forward. It's sort of the halfway point between us hitting, I'd say an Octane 2.0 release, which will be sometime next year. And I guess the biggest feature that we've added, which I think is a huge one, is we've made the renderer 4 times faster. So everything you were seeing before, and even the speed that you're seeing on the cloud, was using the previous version of Octane. This new version, basically in very complex scenes like this, is four times faster. And that's remarkable. I mean, that really makes that's something that I think is going to either reduce the cost by 4x or just give you even greater interactivity, and it changes a lot. So we're very excited by this. This is a huge breakthrough. It has a lot to do with really how the way lights are sampled, and it just gives you noise-free rendering in a quarter of the time. So that's a huge leap forward. There's a couple of other features that we're adding in Octane 1.5, and this is something we're going to have out in beta in about a month. This is big, Limbic importing and exporting. And this is not just in the standalone version of Octane. This is across all of the plugins that Octane will support. So if you're, let's say, inside of Blender or 3D Studio Max, and you've built a scene with the Octane plugin, you can export that in a Limbic format with all of the materials and shaders and properties, and then you can bring that into the Octane standalone. And we're also, if the plugin developers, our external plugin developers support it, you can also then transfer data back into other programs. So this really does create a very interesting ecosystem. One of the reasons why we wanted to have this feature in there was for the cloud service. Really, now that we have this in Octane 1.5, when we launch the Octane cloud service, beyond the small beta that it's in now, you'll be able to really not just export a Limbic data from any application that Octane supports, but also then upload that to the cloud and then render that server side. The other thing that we've added are more UV transform nodes, which will make it much more robust. We're also adding visibility groups, which has been a big feature request. And then the other big thing, which is something that we promised initially when we were talking about the feature set we wanted to have for Octane, is that the entire API is scriptable. Now, the API for Octane is very powerful. That API is what's used to build all of the plugins for all of these apps, including the Max plugin. And now end users or third-party developers, without having to get that SDK, will be able to really access and modify almost any part of the Octane application, including the UI and including creating widgets. And that's something that will also be baked in to all the plugins. So that's something that we're very excited about. The scripting is based on Lua, in fact, Lua JIT, so it's going to be just as fast as compiled code. And that's going to allow us to really expand enormously the ecosystem of tools and utilities that are built around Octane. So all of this, again, it'll be in beta in about a month. One of the things I wanted to focus on next was how we're dealing with skin rendering and also physical materials, right? Because, I mean, it's one thing to have a really awesome physically correct renderer like Octane, but it's another thing to get those materials to end users. So, one of the things that we've done is we provided a database built into Octane called LiveDB, where you can download and share materials with others, and there are a lot of materials in that already, and all the plugins can access that. When you're dealing with skin rendering, we have, for example, skin shaders that are built in, and this is one of the users made this, and it's a great scene. It's a great visual. Going forward, what we want to do is we want to provide even richer data sets, even richer materials for users to use. Now, that really feeds into another part of what OTOY does, which is reality capture and material capture. And that's based around another part of our company called LightStage. So LightStage has been around for a while. In fact, it was created at USC by Tim Hawkins and Paul Debevic. I don't know if you guys are familiar with their work, but Paul is really the father of HDR rendering, and he's been a fantastic resource for OTOY. And they initially created LightStage at USC, and then we commercialized it. And we've been using LightStage for high-end film productions. But really, going forward, we want to try to integrate all of that amazing technology into more diverse production pipelines. And Octane and what we're doing at OTOY is a big part of that. So I'm going to talk a little bit about LightStage. Firstly, one of the things that was really exciting, about 3 years ago, LightStage actually won an Academy Award for the work that you're about to see in all of these films. Starting off with Superman Returns for these amazing CG doubles. And the way that LightStage works is that you don't just capture geometry or texture. You actually get the full BRDF. You get the full lighting equation for anything that you put in a LightStage. And Sony ImageWorks was one of the first companies to really utilize that properly. And they did it as early as Spider-Man 2 and 3 and Superman Returns. And so you can see these shots with Alfred Molina here. the CG double looks perfect. And there isn't a lot of work that the artist needs to do to get that to look good because it's built into the Lightstage data set. And if you really take the path that Lightstage has been on, you start to see, moving away from just doing simple capturing of actors and digital doubles, you start to see it used in more complex ways. So it was used, for example, to create the older Brad Pitt in Benjamin Button. And it was also used on Avatar. I believe the scene with Sigourney Weaver at the very end, hopefully I'm not spoiling it for anyone, where she's about to die, that was scanned in on Lightstage, in Lightstage 5 at USC. And so there's a lot of amazing work that's been done with this technology. And I think that when we look at where it's all heading, I mean, there's a lot of convergence that can happen with cloud rendering, Octane, and Lightstage. So I want to show a couple of use cases more recently than some of the earlier work. And this was Avengers. So we worked on this with ILM. We provided data sets for Mark Ruffalo. And ILM did some just absolutely amazing work with this data. So they graciously lent us this video to showcase how they put the Lightstage data to use. And you can see the Lightstage data on the left and their digital duplicate based on Lightstage data on the right. And it looks pretty good. I mean, it looks just about real. And so this was a case for a film that just obviously came out last year where Lightstage was really put to great use. And you can see it in this shot as well. So what's exciting about Lightstage is that we're moving away from just, again, simple capture to being able to change and transform the data that's captured from Lightstage into novel things. And so, of course, that enables these amazing types of scenes like this, where you see poor level detail and all this amazing stuff. And of course, a lot of that is done by ILM artists. But what gives a solid base to that is the Lightstage. And you can see the actor being captured in our facility at Burbank. We're working on portable Lightstages this year, so we want to see Lightstage really get more commoditized. And I think that there's even the possibility of seeing Lightstage type technology being turned into something that can be attached to a tablet or a mobile phone. But as this technology matures, I think that you're going to see the ability to really start to get incredibly fine detailed, not just in geometry, but again of surface details. And so we've been experimenting again, trying to replicate this, instead of, not just with a big expensive Lightstage that's fixed or even movable, but also just with simple LED lights and other types of technology. And I guess the other area where Lightstage really has a huge impact on is video games. So one of the things that I think you guys may have seen around the show and at the NVIDIA booth is Digital Ira. So Digital Ira was a prototype video game character done with the Lightstage technology at USC. And I don't know if you guys have seen this, but this was a test that was done with the Lightstage data by Activision. And this is all real time. This is all just DX11 shaders, and it looks really great. It really does sort of show what you can do, with, again, a Lightstage data set powering this kind of interactive digital character. So going forward, we want to integrate all of this inside of Octane. And we have subsurface scattering in Octane, so we have the tools to actually physically and correctly render skin. So what we want to do is provide a path that allows you to take Lightstage captures or have a basic Lightstage, head or body data set, and then bring that into Octane and essentially have it ready to go. And not just as a skin shader, but also as really a human base model. And this is showing really how Lightstage data rendering inside of Octane looks. It's really nice. And of course, these renders are really quick. I mean, they just take a few seconds on a high-end NVIDIA card. But the quality is spectacular. And this is something that, again, we really want to democratize and see in everyone's hands. So going forward, the next phase, of course, is getting all this to be even more interactive. And part of that work has to lie outside of Octane. Octane is focused primarily for artists and for a final render. As fast as it is, as interactive as it is, we don't want to compromise ever on that. But there is a lot of interest in taking path tracing and all the high quality work that we're doing with Octane and having that being used for games. And what we've done in that vein was to develop a separate renderer. And it's called Brigade. It's basically the code name for the renderer, but it's being integrated into essentially a single API along with Octane. So you'll be able to select whether it's any plugin that Octane currently supports. You'll be able to select Brigade as an alternative renderer. It'll also be baked into our cloud service so that developers can just target this API directly and build games around it. And Brigade is very interesting. Its biggest feature is that you can dynamically change the scene and still have real-time path tracing. So this was the demo that we provided, or that we showed, I guess, at GTC in March. And it was running on 3 GPUs, which is still a lot of GPUs. But it's remarkable for the fact that you can see with this kind of technology, we're not that far from being able to use this for video game engines, and we want to see that happen. It's remarkable. I mean, there's definitely a point. It's probably around 10 million polygons where ray tracing will be faster than rasterization. And of course, once you're in ray tracing, you can do things that you can't do with rasterization. You can have billions or trillions of polygons. If you guys go online and see some of the other videos, they're just it's crazy the amount of detail that you can have in this. Now, one of the big things that we need to do with Brigade, and we've always recognized this, is we need to get rid of the noise. If this is going to replace DirectX or OpenGL, and we want it to, then we have to have this on a single GPU be noise-free. So there's 2 ways that's going to happen. One is the GPUs will just get faster, and they will. I mean, when you look at where Maxwell's heading and Volta after that, I mean, there's going to be pretty significant speed increases, and that might get us from 3 GPUs to 1. But there's other alternatives that we're exploring to speed up Brigade. One of them is we want to work with other middleware providers to make the entire pipeline for Brigade seamless. And one of the things that I decided we should do was work with a company called Silicon Studios. And if you guys remember, the very first implementation of HDR in DirectX was done by a developer called Masa Kawasai. And he works at Silicon Studio, and he created Yebis, which is a post-processing pipeline. And that's been integrated in Brigade. So it gives you real-time motion blur and depth of field and other effects that we can combine with Brigade in really interesting ways. But really the big step forward for us, and we just announced this yesterday, is Brigade 3. And it's an entirely new version of Brigade. It hasn't been shown until really now. And it's a 3x speed increase. So what this finally does is we can now run the same demos you guys were seeing before on just one GTX Titan. And we're there. I mean, we're running on 1 GPU, full path tracing, 35 to 60 frames a second. And that's remarkable. And we're also getting the, I guess you can call it the voxelization process, or the process by which we can dynamically change the scene to be even faster. So if you look at how quickly we're able to recalculate, this is rendering in Brigade. It's just now we're really at the same speed as DirectX or OpenGL without any real compromise for your viewport, except that it's not really DirectX, right? I mean, this is now, it's fully ray traced, and it's rendering in real time on a single GPU. And that's a remarkable breakthrough. So these 3x and 4x speed breakthroughs that we're getting in Brigade and Octane just in the last 4 or 5 months changed the game entirely. This means you can have 1 GPU that you can buy at Fry's, like a GTX Titan, and have path tracing now for games, for film rendering, all on your own machine. And of course, the cloud is always available to push that even further, to go to 8K rendering or whatever you want to do. But getting that to run on a single graphics card is important. And the reason why that's important is that as you look towards the future, we don't just want to have the cloud be the only place where Brigade and Octane can really be used on mobile devices. You look at things like Logan, which are essentially a Kepler card on a chip in a tablet. That means that we can bring Brigade and we can bring Octane to those devices as well. And I think Brigade especially is interesting because that is going to be possible to do ray tracing on that end device and do it very quickly. So the reason why I think that that shift will happen is really because displays are changing. We're not just limited to what you see in a 2D display now. I mean, you have things like the Oculus Rift, which interestingly enough also came out of ICT research. If you look at the history of the Oculus Rift, there's a number of devices that preceded it that were developed really out of trying to turn a phone into a stereoscopic virtual display. And the Oculus Rift is the evolution of that. And so Brigade already supports the ability to render directly to the Oculus Rift, not just at 60 frames a second, but 120. And the reason why that's possible is that we can basically take frames, we have all the vector, the motion vectors, and we can then just do reprojection at a much faster rate than what Brigade's actually rendering at. And that is absolutely critical for these kinds of displays. So we're very close to being able to provide noise-free path trace rendering without all the overhead that you have from traditional rasterization for these kinds of display devices. I think that there is another level above and beyond what you can do with head-mounted displays, and that is straight-on holographic rendering. And in that case, the cloud does become an important part of that, because holograms, if you're talking traditional holograms, there's a lot of data that goes into them, and it's not just stereo views, right? If you're talking about a real hologram, you're talking about hundreds of thousands of views that need to be calculated. But with the cloud, that doesn't really cost much. It doesn't become much of a problem, and especially with a path tracer like Octane, one of the other little hidden gems in Octane 1.5 is that you can take the scripting capabilities and you can generate holograms with it on the cloud or even on your own machine. And so we are going to be providing a Lua script that allows you to do that for Zebra imaging prints. And if you guys aren't familiar with Zebra imaging, it's this fantastic service that allows you, you can send it a 3D model, and it'll actually give you back a holographic print for a few $100s. What we're going to do is we're going to essentially save into that format right from Octane and generate all those views in a way that has never been possible before. I think that's something that'll be pretty exciting, and it also sort of really is a first step towards true holographic displays, right? And these are still images, and I think that as you start to get towards these next-gen displays, holographic rendering is going to become an important element. It's something that you also want to have really in place when you're talking about any kind of shared viewport where people are going to be seeing in stereo, right? I mean, that's kind of what the Oculus Rift doesn't quite do that, but holographic displays will. And towards that end, and we partnered with again with ICT on something very exciting. And I've looked at a lot of different holographic display technology, and I have to say that the thing that I thought was one of the most interesting approaches was Paul's work in this area. And this was the very first prototype of his holographic display based around pico projectors. And this was something that we showed off in March. It was one of the very first times people had seen this technology. And if you look at this, it's a holographic display that's being using from projection, and it was very basic. But it was an exciting first step. And the next phase of that was to do a rear projection holographic display, and that was even better and even more advanced. And that was only done about about 6 or 7 weeks after the first prototype was completed. And so what we're doing with this technology is working on a rendering pipeline that can stream from the cloud directly to these kinds of displays. The codec that you were seeing at the very beginning of my presentation does allow you to send multiple views down. It does allow you to send down holographic data, and it's not, once it's calculated, it's actually not that much data beyond rendering, one view. And so what's exciting, I guess, about being at this show here is that you guys can actually go see this technology on display. It's at the Emerging Technologies booth, and you can see the final version of this, which includes a couple of extra features. For example, it has a Kinect that tracks your head, and you can see digital IR being rendered on this holographic display. So that's an exciting development to sort of have this technology out of the lab and on the show floor, and I encourage you guys to go check it out. It's a really amazing breakthrough, and it connects very deeply with a lot of the technology that we're working on, both for rendering and cloud streaming. So I think that does it for the demos. Is there anything that I can do to answer questions or comment on any things you guys just had seen or heard?